Welcome to lecture number 8. This lecture is focused on the dot product. We'll start with the definition. So dot product of two vectors in R2 or R3 is denoted U dot V, and it has two equivalent definitions. One is in terms of the components, and one is in terms of the magnitudes or lengths of the vectors. So let's do an example. And we'll, in this example, use both definitions and show that they give the same answer. So we'll consider the vector 1, 0 and the vector 2, 2. And these are both in R2. So these are two-dimensional vectors. And we're going to compute the dot product two ways. All right, the component-wise way of computing the dot product is the easiest. You just multiply the first components and then the second components, and then you add those two products together. So 1 times 2 plus 0 times 2 is 2. So that's the first way. And then the second way, we're going to illustrate this way with a picture. So 1, 0 is this vector, and 2, 2 is this vector. So the dot product of those two vectors, we'll call this one, for the sake of the argument, U, and this one V. So the dot product is the lengths of the vectors, the length of U times the length of V times the cosine of the angle. And you can see with this is a 45-degree angle. 2, 2, that's a 45 triangle. So the cosine, we'll have the cosine of 45 over here. We'll have the length of this vector. Hypotenuse of the 2, 2 triangle. Draw a little right triangle here. Hypotenuse is 2 root 2. So the length of this vector is 2 root 2. And the length of this vector is 1. And simplifying this, cosine of 45 is 1 over root 2. And this product, when you cancel the root 2's, you'll get 2. All right, a little more complicated. So we typically compute the dot product with this component definition, but we'll use this other definition frequently when we're trying to find angles or do applications, which we'll talk about more later. All right, let's do another example. So in this example, we're going to match vectors with statements about the dot product. So we have three statements. First is U dot V is greater than 0. Second is U dot V is equal to 0. And the last is U dot V is less than 0. And then we'll have three scenarios. The first scenario is U and V are perpendicular. So the angle between them is 90 degrees. Second scenario is U and V are pointed in different directions, but the angle between them is less than 90 degrees. And the third scenario is U and V are pointed in different directions, and the angle between them is greater than 90 degrees. Okay, so acute angle, obtuse angle, and right angle. All right, so we're going to look at the second definition of the dot product. So recall the dot product is the lengths times the cosine of the angle. And notice that both of these are going to be positive quantities. Lengths are always positive. So the only way that the sign can change, is if the cosine is negative. So this will possibly be negative. Could be positive too, or 0. Also these are both positive, and in all of our examples they're not 0. So they're not 0. So this could be positive, negative, or 0, the cosine. So the cosine is really going to distinguish these three cases and line them up with these three statements. So first thing to note is that the cosine of 90 degrees, the cosine of a right angle, is 0. So that means that this dot product is 0 corresponds with the angle between them being 90 degrees. Okay, and that's one of the most useful properties of the dot product. If you take the dot product of two vectors and those vectors are perpendicular, there's a 90-degree angle between them, then the dot product is going to be 0. That allows us to use the dot product to check if vectors are perpendicular. And then if it's greater than 0, well, the cosine of an angle between 0 and 90 is a positive number, and you can see this with just looking at the cosine. At 90 degrees, pi over 2, it's 0, and it's positive in this region, and it's negative in this region. And then here we're at 180 degrees, or pi. All right, so being positive means that the angle between the vectors is acute, and being negative means the angle is greater than 90 degrees.